Okay, so everyone remember what happened this at the beginning of the lesson. We learned something. Oh, wait. Okay, read the question first. So Mike multiplies at least 2 consecutive integers together. So they're integers that occur right after each other. He obtains a 6-digit number n. First 2 digits are 4, 7, 4, 7. And then there's 2 in between, and then ends with 74. Cool. We don't know what these two are, but we can definitely use this information to figure out how many integers Mike multiplied together. What is the sum of integers that Mike multiplied together? Okay, so we're going to first deal with this part of the question. At least 2 consecutive integers. So that already gives us one unknown. And the unknown is how many integers did Mike multiply together? So what we learned this at the beginning of the lesson was that the product is just 2. 3 factorial is 6. 4 factorial, 24. 5 factorial, 120. 6 factorial is 720, I think. Yeah, okay. 7 factorial, 5040, or something. Yeah, it goes on. Okay, so does someone want to tell me what they can conclude from this array of factorials along with this fact here? Remember, we're trying to answer the question of how many integers did Mike multiply together?
It wasn't more than 4, so it was either 2 or 3.
Amazing. Actually, it could be 4, right? I mean, just based off this information, we don't know that it's not 4.
No, it can't be 4 because 74
Mm.
isn't a multiple of 4.
Okay, actually, that's good. I actually didn't go that far yet. Okay, good. So does everyone understand that we can just look at the last digit of each of these things, and we notice that, well, these are all zeros. And obviously, if you multiply something with a last digit of 0 by anything, then the last digit has to be 0. So all of these will have last digit 0. And we can eliminate all of these because there is no way we can multiply something by something with a last digit of 0 and get a 4 at the end. So all of these are eliminated. It can't be that many integers. And now 4 integers consecutively is eliminated also because we can just look at the last digit here. Actually, is that true? Because so basically, Finn, I'm not sure if we can eliminate that yet, just because it's possible that the 20 contributes to the 70.
No, because it has to be a multiple of 4, and so to get a multiple of 4, you only have to look at the last 2 digits. And so if the last 2 digits are a multiple of 4, then
okay, so
number
that's
is
general.
And 74 isn't. So
yeah, okay, nice. So that is using just a general multiplication principle. Any multiple of 4 has the last 2 digits divisible by 4. And I'm sure that can be proved relatively easily, but we're not.
Yeah, it's basically just that 100 is a multiple of 4. So everything else is a multiple of 4.
Oh,
so
okay.
The last 2 digits, yeah.
Yeah, okay. So basically, yeah, the idea is if you just look at the first 4 digits, and chuck a 0, 0 on the end, that's definitely multiple of 4 because 100 is a multiple of 4. And so it only remains to check that the last 2 digits are a multiple of 4. Okay, nice. That's a pretty neat rule. Okay, so yes, if something is a multiple of 24, then because 4 is a divisor of 24, then necessarily the whole number has to be a multiple of 4. But 74 is not a multiple of 4, so there's no way that it's 4 consecutive integers. Okay, awesome. And also, I think that it is also not 2 consecutive integers. And we'll go through that now. So if it is 2 consecutive integers, let's say m and m plus 1, that means that m plus 1 has to equal this weird thing, right? Dot, dot, 7, 4. Okay. And so that means that if we square m, because I'm just expanding this now, m squared plus m, we get 4, 7, something, something, 7, 4. Okay. But again, we're going to do this trick of looking at the last couple of numbers. So just in general, I think probably the 47 will come in handy when we're trying to work out the exact values. It'll give us a general idea of how big our numbers are going to have to be. But the 7, 4 is what we're looking at now in order to eliminate other possibilities. So we,
I get it.
yeah, so we eliminated, yeah, okay, so Finn probably already worked it out that it can't be 2. But yeah, we eliminated all of these just based on the last 2 numbers, which is pretty powerful. And we're going to eliminate 2 just based on the last 2 numbers. Okay, so what I'm going to do is I'm going to just look at all possible last digits of m. So possible last digits of m, because that'll give us an idea of what the last possible, that'll give us the, that'll give us the last digit of the big number. Oh, okay, cool. This is different to what I thought, but I like to see new methods. All right, we'll go through both. That's cool. 7, 8, 9. Okay, so basically, let's say m is even. Then even multiplied by even is even, plus even is also even. All right, well, that's, I guess, not interesting. Now,
Oh wait, no, never mind. It doesn't work because of m, not never mind.
oh, okay, okay. That was a very good idea, though. I think it didn't even occur to me. So if it did work, it would have been a lot faster than this method. But basically what I'm doing here is these are the possible last digits of m. I'm just going to square each and then add it to itself and see what I get. So we'll go through why in a bit, but basically 0 squared plus 0, 0 squared plus 0 is just 0. Cool. 1 squared plus 1 is 1 plus 1, which is 2. Okay, 2 squared is 4, plus 2 is 6. 3 squared is 9, plus 3 is 12. I'm going to get rid of the first digit because, like I said, I'm only looking at the last digits of everything. So I'm going to put a 2 here. 4 squared is 16, plus 4 is 20. So the last digit is 0. Cool. Someone can help me fill this out. 25 plus 5. Thanks, guys. This is very productive. So there's a 2 here. 6, 2. Great. Okay. Can anyone see any 4s? No. No 4s. Great. Okay, so let's recap on the method here. So the idea was these are my possible last digit of m, last digit of m. And if I'm going to square m and add it to itself, then if I want to look at the last digit of the result, it's enough to just square the last digit of m and add that to itself. And the reason is because if I consider the tens, so let's say m is like, 46, well, the effect of the 40, squaring that and then adding it to itself is only going to contribute a last digit of 0. And you could argue that okay, I guess we've got to do this a little bit more systematically. Okay, I guess let's just look at 40 plus 6 all squared. This is where our binomial formula is going to come in handy. There's every chance that I've done a mistake here anyway. 1600, so that's 40 squared, I think, plus 2 times 40. Okay, yeah, times 6 plus 36. Okay, cool. So this has a 0 at the end. So the 40 squared does not contribute to the last digit. This is going to have a 0 at the end because there's a 10 here. So again, 0 at the end, it doesn't contribute to the last digit, but the 6 does contribute to the last digit. So on top of 46 squared, we need to add 46 again, right? If I'm looking at m squared plus m. But again, adding the 40 does not contribute to my last digit. So it's enough to just look at 36 plus 6, which has a last digit of 2. And so it's enough to look at the last digit of m, square it and add it to itself. And this gives us the last digit of m squared plus m. Last digit of m squared plus m. Okay, so this is great because there's no 4 here, which means there's no way that we've got 2 consecutive integers, since we know that the last digit of our m squared plus m is 4. Okay, now this part, I guess we're going to do together, but I think we've done a pretty good job by determining that it's got to be 3 consecutive integers. And that's thanks to this fact here that you learned literally at the beginning of this lesson. Okay, so I'm going to start from scratch. 4, 7, 0, something, something, 7, 4. Okay, so we're working together here. I haven't actually gone through how this is going to go. So it'll be interesting to work on this together, and I want everyone to chuck their ideas into the chat. That was quick, yeah. Okay, that was very quick. All right. Yeah, spoilers. Anyway, I guess I'll just go through what I was thinking. I was thinking of doing m minus 1 times m plus 1. And I did this instead of like m plus 1, m plus 2, because I think it's just a nicer thing when you multiply it out, because the difference of 2 squares, when you expand that, becomes m squared minus 1. Then you multiply that by m. So you just get m cubed minus 1. And then from this, if you perform a similar trick to what we did down there, and you are, oh, sorry, yeah, m squared minus m, my bad. If you perform a similar trick and you evaluate all of the last digits, you end up, so like, if we cube 0 and then subtract it, cube 1 and then subtract it, cube 2 and then subtract it, you end up with the fact that the last digit has to be either 3 or, sorry, the last digit of M has to be either 3 or 8. 3 or 8. So I don't know, we can actually do this, and probably other people have a quicker method, but this is just what I naturally jumped to because I did a similar method to what I did below. Anyway, 3, 4, 5, 6, 7, 8, 9. Anyway, so 0 cubed minus 0 is 0. 1 cubed minus 1 is 0. 2 cubed minus 2 is 6. 3 cubed minus 3 is 27 minus 3, which has last digit 4. Okay, which is why I said, you know, potentially, oh yeah, but it can't be. Hang on. Anyway, sorry. Yeah, last digit is 4. 4 cubed is 64 minus 4 is, so last digit 0. 5 cubed, 125 minus 5, 0. 6 cubed is 216 minus 6, last digit 0. 7 cubed is 343 minus 7, which has last digit 6. 8 cubed is 512 minus 8, which has last digit 4, which is yay, because we need our last digit to be 4. Sorry. Yeah, so it's either 3 or 8, right? Because 4 only occurs with the 3 or the 8. So that means that M has a last digit of either 3 or 8. And I guess from here onwards, if I was doing this competition, I would want to just eyeball it because we have enough information now. We know that, like, you know, the first digit, I mean, we want to get a 47 at the front. So
It's not going to be like 10 or 20.
It's not going to be like 10 or 20. Hang on. Could you elaborate on that?
The first digit isn't going to be like 1 or 2 because it's too small.
Yeah, that is too small. So if it was 1, yeah, like it would probably give us a first digit of 1 again at best. If it was 2, I feel like we would get like an 8. It's got to be at least 7. Okay. So who said that? Why has it got to be at least 7? Okay, well, let's just think about it. 47, 0, 0, 0, 0. And then we've got 3 numbers really close to each other to give us 47, 470,000. All right, good. Someone said 70 cubed is 343,000, which is less than 470,000. And so, yeah, there's no way. Yeah, good. Okay, so this is what I mean by eyeballing. So we just check the biggest contributors of the number. Like, we'll just think about 47 and pretend there's zeros everywhere else. You know, it's somewhere in this range. It's somewhere 47 with something after it.
It has to be between 70 and 80 because of the range.
Okay, so first of all, it's probably going to be 2 digits, right? Because 2 digits and then you cube that gives you numbers with the right order of magnitude, because it gives you numbers with 6 digits. And if you do 70 cubes, we get 343,000, which is smaller. And then if you do 80 cubed, get 512, which is too big. So we've already refined it. We know it's got to be between 70 and 80. So M has to be between 70 and 80. But then we've also determined that the last digit is either 3 or, wait, my bad. The last digit is either 3 or 8. So that means we can probably just check m equals 73 and check m equals 78 and see which of those works. So this is pretty nice, right? We ended up like, what do you call it? Yeah, we ended up turning a really open-ended question into something where we only have to check 2 values. And each of these just require 2 simple calculations. I was gonna say you just type it into your calculator, but then I realized no calculators are allowed. So I guess your basic arithmetic would be worth brushing up on for this competition. And yeah, 73 won't work and 78 works, I guess. Yeah, does anyone have any questions? Okay, let's see what our main takeaways are. Okay, so again, this is the type of question that's checkable. You can check that your answer is correct and be absolutely certain that you've got the correct answer. So, and that's great because this is a 10 marker. This is the last question of the paper. And so they're just giving you a question that's worth heaps and is a guaranteed victory if you solve it. What else? I think we learnt different ways to treat different parts of the question. So there are so many unknowns in this question. And I think it was wise to refine our initial question to, okay, first of all, how many integers are multiplied together? Because without knowing that, it's pretty impossible to do anything that will give you what exactly the integers are. It's important to know how many there are. So it's kind of natural to work on this problem first. And I guess there was a bit of combinatoric theory involved. And honestly, I don't think I would have been able to eliminate the rest without seeing this fact. But yeah, it's pretty nice that we managed to get rid of all of these and determine that it's got to be 2 or 3 integers. And then what we did was looked at the last digit, which is probably a common tactic when it comes to, especially if you're given the last digit, probably a common tactic when it comes to multiplying numbers and stuff like that. It's quite nice because m squared plus m is kind of a simple expression. And so you can look at all the possibilities given that it's going to be of this form. And then the nice thing is we just carried the same tactic over to 3 consecutive integers. And I also hope everyone understands why we went with m minus 1, m plus 1, as opposed to m plus 1, m plus 2, because that gives you something that's a little bit messier. I mean, you could do it, but I guess it would just take a little bit more time. And so if your aim is to do the most questions and get the most points in the shortest amount of time, this one's probably the best expansion you can do. And yeah, we narrowed it down to 2 things. And because that's actually not much to check at all, we can just go straight to eyeballing the answer based on our given information. So it's like at this point, we sort of think to ourselves like, wow, I have quite a lot of information now. I know that it's 3 integers and I know what the last digit has to be. And so at that point, it's sort of wise to stop trying to find tricks and just eyeball it based on the other information that you have. Okay, great.